All right, looking at worksheet B for chapters 8 and 10, so just some more statistics stuff. So number 2, given a set of grouped data, so we got data within groups plus a frequency list to go with it, so an estimate of the mean. So for something like this, of course, you could do it by hand, but definitely an easier way to do this in a calculator I'm going to show you. So you remember the traditional way, if you're going to do it by hand, would be to add up all the terms, divide that by the number of terms, and then that gives you your mean. So if you wanted to find the sum of all your terms, for these guys, whenever we're dealing with groups, when we're given classes of data like this, we don't know what the actual value is. All we know is we have 28 of something from somewhere from 0 to 40. They could all be 28 ones. They could be 28 39s. We don't know. So what we do is we just take the number in the middle. So we call that the mid-interval. So the mid-interval from 0 to 40 would be 20. So like if I just did like find the average, 0 plus 40 divided by 2, that gives me the mid-interval. So the mid-interval would be 20. So we just assume that I have 28 20s. Then I would have 18 60s, 24 100s, so on and so on. If I found the sum of all that data and divided it by the number of terms, which would be the sum of my frequency list, that would give me my average. So that's one way you could do it, but of course there's an easier way in the calculator. So for these guys, we just go back to Stat, go to Edit, and we're going to put in our list of data. So let me clear out the old stuff. So in list 1, I'm going to put the mid-interval of each value, so 20, 60, 100, so on and so on. So 20, 60, 100, 140, 180, 220, and 260. So there's our mid-intervals for each of our groups of data. And then you're going to put your frequencies into list 2. So if you put that bottom row, your frequencies into list 2, that's what that would look like. Then we go to Stat, go to Calc, one variable stats, and we have our data within list 1 and our frequencies in our list 2. So if we hit enter all the way down, you see up there at the very top 114, approximately 115 would be the average or the mean. So it says the estimate of the mean, so we just want to round that off to 3 sig figs for something like that. So moving on to step 2, part B. Now we have an incomplete frequency table that we're using, and we're going to create a cumulative frequency graph with these guys. I'll come back to the scale here in just a minute. Let's just talk about completing the table. In a cumulative frequency, you're adding as you go. So with cumulative frequencies, the first set of data is everything up to 40, which you can see there was 28 values from 0 to 40. And then in the next one, it's everything from 0 to 80. So if I add up the 28 plus the 18, I get 46. Then in the next one, it would be from 0 to 120. And so I now add 24 on to what I already had to get the next guy in the table. And then again, I now add 50 on to what I already had to get the next part in the table. And you just keep doing that all the way through. So it's a cumulative frequency. You're adding as you go. So again, every time you see something like this, this means the sum of everything from 0 to 200. And so you're just adding from, if you were to add up all those numbers, that gives you that guy in the table. So that's how you would complete the table. As far as making the graph, a couple things. I mentioned this in an earlier video, but as far as the scale goes, if you look at IB graph paper, every fifth line is darkened. And so every fifth line is considered 1 centimeter. So based on this scale that we have right here, it means every fifth line or every darkened line that you would see on their IB graph paper is 1 centimeter, and we're going to represent that with $10 in order to fit this scale in there. Same thing with the other axis. Every centimeter would represent 10 customers on the vertical axis or the y-axis. So that's how you would scale your graph. Anytime you're doing a cumulative frequency graph, so a couple things you would want to do for this. One is the data points that you plot. The first one is always 0, 0. And then the guys that you're seeing in this table, where you have the upper class limit, right? The 40, the 80, the 120, those are your upper class limits. And then you have the cumulative frequencies below. So on the graph, your data points are the upper class limit is your x, and the cumulative frequency is your y. So the first point that you would plot after 0, 0, because you always start with 0, 0, after 0, 0, this would be your next point. So the 40 would be your x and 28 your y. This would be your next point, so 80, 46, and then your next point, and so on and so on. So plot those points, and then starting at 0, 0, you simply make a smooth curve through those data points. And so that's all you'd have to do to create the graph for that. So if you wanted to see what that would look like, you can see in our worked out solutions. Here's how that would have gone for us if we do that. So a couple of ways that you're graded on this. One is you have to make sure you show your scales. The other is you have to start from 0, 0. The other is you have to make a smooth curve through the points. So they don't want like a rigid connect the dots kind of a graph. It's a smooth curve through the points. You should also be labeling your scales. This one did not, but you should be labeling your scales. For example, we should have dollars on one axis and then customers on the y-axis. So we always want to label those axes as well. So if you're an IB test taker, that's something you want to make sure you do all those things. So now the time in minutes spent by customers could be represented by this function here. So use this equation. Notice it says use the equation, not your graph. So we can get stuff from the graph for sure, but this one specifically says use the equation. So and our answer from part A, which was the mean that we got out of our calculator, to estimate the mean amount of time in the minutes spent by customers in the store. All right, so we're going to take our answer from part A and put it in for D, which was dollars. So remember, in part A we had the average amount of dollars. The average amount of money spent was about 115. So if we take our 115 and sub it in for D for dollars, we can figure out the amount of time that they would spend on average using the average amount of dollars that was spent. So we just plug in the 115 for part I. So now we're using the equation and the graph. So now we're gotta go to the graph for some of this to estimate the number of customers who spent more than 42 minutes in the store. So for this part, before we can get to the graph, we have to find out our dollar amount from the graph that we need to take a look at. So in this case, number of customers who spent more than 42 minutes in the store. So in this case, if I take my 42 minutes and plug it in here, because remember, time is not represented on our graph. On our graph, we have dollars and we have numbers of customers. We don't have time on the graph. So I have to take my time, sub it in order to get the dollars, so I can use the dollar amount on the graph to then get the number of customers. So we got to kind of track through the process here. So 42 minutes, if we sub that in, so time was 42, and so now we're using this to solve for the dollar amount. So if I subtract my 4, I divide that by 9, and then do a third power on that one. So that's going to give me the dollar amount that we want to take a look at on the graph. So let me punch that in here real quick. So that comes out to be about $75.3. So for this guy, now is where I can turn to the graph and say, okay, let's identify $75.3 approximately. This is not an exact science because everyone's curve could be just a little bit different. So they typically on the IB test, they give a range of possible answers for this, but so it needs to be close. But so we remember that we had dollars down here, and our customer base, or our number of customers, was the y-axis. So I know that dollars is 75.3, which must means I need to start on the x-axis, and we're going to track that up and over to get a value on the y-axis. And so again, this is not like an exact science right here, but if we approximate the number of customers for that answer. So remember, the scale that we were counting by was by tens. So we would say maybe about 45, 46 would be my estimate from the graph. But like I said, it's not really an exact science because you can see like wherever you would hit your curve and trace that over is is about the answer that you're given. Let's call that 45. At least that's what I would have said. Like I said, the IB test would give like a small range of possible answers, so they might accept anywhere from 44 to 46 maybe on this answer. So, but this one said customers that will spend more than a certain amount of time. So what that means is they are now talking about all of these customers here. So it was everybody who spent more than a certain amount. So they're talking about all these people in that area. So remember, this graph went all the way up to 150 at its highest. So what they are talking about is everybody from customer 45 all the way up to 150. So we want to know how many people are in that area of the graph. And so because it said more than. So in this case, I'm just going to do my 150 minus 45 is going to tell me how many people are in that area. So that's how I would get the answer to that part of the question. Moving on. And then the last part on this one, it says 60% of the customers spent less than 8 minutes, so find the value of A. So again, a couple things we want to recognize. We got 60% of the customers, so remember there were 150 customers total. So 60% of that means we're talking about 90 customers here. So we're talking about 90 customers who spent less than 8 minutes, and remember, time is not on our graph. So that means I have to use the graph to get a dollar amount, so I can plug the dollar amount into here in order to get time. And so for this one, 60% of customers, so that was 90 customers, and because it said less than A, that means I'm talking about the first 90 customers, the bottom 90, not the top 90. So I'm looking at the bottom 90 customers, or the first 90 customers, and so if you see on the graph, that's what you're seeing right here with this line. So this would be about 90 customers, and so if I trace that over and down, I should be hitting pretty close to 140. Again, this is not an exact science. It's an approximate, so we would accept a small range of answers. So I would have said about $140. That would have been my answer. But again, you just need to be close to that. So now we have our dollar amount is $140. So I can go to my function and I can just plug in my 140 into the function that they gave us in order to get my amount of time. So I would plug my 140 into that in order to get time. Okay, moving on to question number 3. So looking at this one, so again, given a list of data, we're told the X's are in kilowatt hours, and we're told that the Y values are dollars. So 2 separate lists, which means these are now 2 variable statistics, not a frequency list, but rather 2 different variables. So that's kind of the difference between number 2 and number 3 from this worksheet. So equation of the regression line, a lot of this is just going to be going back to some calculator stuff. So again, you're going to go to your list of data within your calculator. So you go to Stat, Edit. Let me clear out the old guys. So if you go to the top and hit Clear, Enter, it clears out the old ones. So let me take a minute to plug in my data values. So there we go. So I got my list of data in my calculator. Go to Stat, go to Calc. Go down to option 4 where it says linear regression AX plus B. So in option 4 we got the X's are list 1, my Y's are list 2. We do not have a frequency list for this. So if I go all the way down, I'm given all the information I would need here. So a couple things you get off this page. They give you the format. We would sub in the 0.0256 in for A and the 5.51 in for B. And then that would be the equation of that regression line. So round those off to 3 sig figs. Remember, your leading 0 does not count. And then you also get the correlation coefficient on this page as well. So that's why these guys always kind of come together for the regression line and the correlation coefficient are both found on the same page. So about 0.562 would be the correlation coefficient or the R value for that one. So That's where we got the regression line for that, as well as the correlation coefficient. So the estimated cost of producing, notice the kilowatt hours were the x's as stated up here. And so that's an x value, so I would simply take this 38 and plug it in for x into the equation I just got for part A, and that's going to give me the cost, which is the y coordinate. So estimate the cost of producing 80 kilowatt hours. Again, that's not any different. You would now just plug in the 80 in for x as well. So limitations on B and D. So here's the big difference. All this is based on the x coordinate only. So if you looked at the x's, if I plug in a 38, notice the lowest point we had was 30. The highest point we had was 50. So 38 is a number between 30 and 50, sorry, 54. So it is a number between 30 and 54, which means it is in the range of our data. They also call that interpolation. So we would say, yes, we would accept the results that we get from this. It's a valid process. However, for this one, we would say it is not valid because it is extrapolation. 80 is not a number within the range of our data. So they call that extrapolation, which means this is not a valid result that we're getting on this. We would not rely on this answer because it's not within the range of our data. However, we do rely on this answer is a valid answer. So moving on to F, the homeowner receives from the utility company 16 cents per kilowatt hour. So for this one, on this one, what they're asking is to compare the cost function. So remember, this is like what it's costing the company per kilowatt hours, right? It's production cost. So this is what it costs the company. This is what it costs the customer. And so in terms of a company's point of view, this is where they make their income, and this is their production cost. So in order to make a profit, that means that their production costs, their production function, needs to be smaller than their income. And so they need to make money on this for a profit, so they need the income to be greater than what it costs them to produce. And so in this case, it's 16 cents per kilowatt hour. So we're saying 16 cents per unit, right, per income unit, needs to be greater than the production cost. So we're plugging in this AX plus B in for this guy. So we had our 0.0256x plus 5.51, I think. So again, this is what it costs the company, and this is the company's income per unit. So we need the income to outweigh the cost in order to make a profit. And so now we're just solving that equation for x. So maybe just start by subtracting that over to the left, and then divide in order to get x by itself. And then that would be your result for x in order to make a profit.